Hello, gang. We're going to talk today about exploring normality and how to determine whether or not a distribution is approximately normal or not. So you should have your notes in front of you. This is the Exploring Normality worksheet in OneNote. You're also going to need your graphing calculator, so if you would get that out and have that ready to go. So the first thing, how can we assess normality? If you're given a data set and it's asking you whether or not this data set is approximately normal, there's a couple of characteristics that all normally distributed data sets have. The first one is that all normally distributed data sets are symmetric. So for number one, list three characteristics of normally distributed data. Number one, it'll let me write, it won't let me write. Number one is that they are symmetric. All right, so symmetry. Number two is that the mean and the median are going to be very, very close to the same number. So when you're looking at a set of data, if you see that the mean and the median are approximately the same, they probably won't be exactly the same, but they should be close. That is one of the characteristics of normally distributed data. And then the third one is that they follow the empirical rule, the 68, 95, 99.7 rule, which we've talked about in class. So you have to analyze the data and decide whether or not it follows that rule. I'm going to show you how to do that in a minute. On the AP exam, if you ever ask a question about is a data set normal, meaning perfectly normal, well, no data sets are always exactly perfectly normal. It would be incredibly rare to find anything that is perfectly 100% normal. So in fact, you would probably say that data sets are approximately normal. That's what we say pretty much all the time. Whenever I'm describing a distribution that I believe is normal, I would never say this distribution is normal. I would say it appears to be approximately normal. If you're given a set of data and you have your answer to questions A and B, list two methods you already know that you could use to determine if the data is normal. Well, we could draw a picture of it and see if it appears symmetric. We could calculate the mean and the median and see if they're approximately the same. And finally, we could do an analysis of the empirical rule, and I'll show you what I mean by that in a minute. Part D, do you think a large set of data is more likely to appear normal than a small set? Yes, absolutely. If you have a small set of data, you could get a dot plot that just doesn't have a lot of dots on it. It would not appear to be symmetric or a bell curve. Whereas if you get a large set of data, much more likely to appear normal. So yeah, larger the better in that case, definitely. Assessing normality. So here's our first example. We want to actually take this data set and we want to decide whether or not it's approximately normal. So here we need our calculators. So I'm going to grab my calculator. I'm going to put this data set in there. So stat, edit. I'm going to clear out all this old stuff. I don't need this old stuff anymore. This is from our transforming variables activity that we did earlier in the week. So I clear out all that old stuff and I'm going to put the new stuff in there. So 4.1, 4.5. I'm going to stop talking now. Data points, and I'm up to 14.7. All right, so we have the data in there. Remember the first rule for normality. Is it symmetric? So we're going to look at either a dot plot or a stem plot or a histogram to see whether or not it's whether it's approximately normal, whether it's symmetric. So I would go up to second stat plot. Now we've talked in class, the best graph to determine symmetry would be to take a look at a histogram. So I'm going to select the histogram. And I want to make sure I have list 1 selected, list 1. And then I'm going to graph it, but nothing showed up, so I need to change my window. So I'm going to go zoom 9. And there we have it. So it's not beautiful, it's not perfectly symmetrical, but it does appear to be roughly symmetrical, maybe a slight skew to the right, but nothing clearly strongly skewed, right? And that's what you're looking for. You're looking for something that is just abundantly clear that it's not symmetric. And this is not giving me that evidence. This looks like this is roughly, very roughly symmetric. So, okay, it's good for symmetry. The next thing I need to do, the second characteristic, is the mean and the median. I need to calculate the mean and the median. So I'm going to go to stat, Go over to calculate and select one variable stats. Select was 1, calculate. All right, so the very top number is 8.6. That is your mean. And if I scroll down, the median is 8.5. So remember I said it's never perfectly normal, but they should be close. So we have a mean of 8.6 and a median of 8.5. They're pretty close. So that's also a good sign. So far it's satisfied the two of the three. It's satisfied the symmetry, it's roughly symmetric, and the mean and the median are pretty close to each other. So now we're going to do the third one. Does the data follow the empirical rule? Complete the table below to find out and analyze your results against what you would expect. So the mean, I said, remember we said the mean was 8.6, and the standard deviation was 2.2. So now I want to do one above. I'm going to do a low value and a high value. So I'm going to take my mean and I'm going to subtract 2.2. So 8.6 minus 2.2 is 6.4. And then I'm going to subtract another 2.2, which is 4.2, and subtract another 2.2, which is 2.0. And then I'm going to do the high values. This is 8.6 plus 2.2. So 8.6 plus 2.2 would be 10.8. Then I'm going to add another 2.2, so that would be 13. And then I'm going to add another 2.2, which would be 15.2. So those are my low and my high values. And now I'm going to calculate the frequency. So I'm going to go up and count how many of them are between 6.4 and 10.8. So 6.4, that would be this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. All right, so this one is 37, which 37 out of 50 is 74%. Okay, then I'm going to do between 4.2 and 13. So I'm going to add on. So I had 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So that one's 48, which is a 96%. And then the last one is between 2 and 15.2, and that's the other ones, 49, 50. So that's everybody. All right, so that's 50 out of 50, and that's a 100%. So the question is, does that follow the empirical rule? Well, it's pretty close. 74% is pretty close to 68%. 96% is really close. Well, it's really close to 95%. And then the 100%, that's really close to 99.7. So does the data appear approximately normal? Yeah, it does. It follows all three of the rules. It's symmetric, the mean and the median are close to each other, and by not doing that analysis with that little chart, that two-way table I just completed, you show that it follows the empirical rule, or at least it kind of closely to the empirical rule, if not exactly right. So that's the way we determine if something is approximately normal. Now, that leads us to something on your calculator called a normal probability plot. If we look at the normal probability plot, here's how you get it on your calculator. You go to your stat plots, and we select plot 1. And when you go down to your type, we've talked about these different types. This first type is a scatter plot, then we have a line graph, then we have a histogram, then we have a box plot and another box plot. That last thing there, that's called a normal probability plot. So if I select that and I do zoom 9, that's a normal probability plot. And what we're looking for is we're looking for a linear pattern. We want to look for a linear pattern, as it says there on your sheet, but don't react to minor wiggles. So if I'm looking at that normal probability plot, yeah, it's a straight line. So based on that, yeah, I would say this is a approximately normal data set. This is our fourth and final test that we can use to determine if something is approximately normal. So first, look at the histogram. Is it symmetric? Second, calculate the mean and the median. Are they close to each other? Third, do the two-way table to determine if they follow the 68-95 rule. And finally, you can calculate the normal probability plot on your calculator. If it is a straight line or a roughly straight line, all those things added together tells us this data set is approximately normal. So that's the way you do it. So what I'd like for you to do is do the next one where you put the data set in and tell me if this is approximately normal, and then answer the last two questions from the textbook. All right, good luck.